chemistry. Structural theory in organic chemistry. Organic chemistry in the study of chemistry of carbon compounds. Next, organic reagents. Organic reagents are broadly classified into three types. One is free radicals, electrophiles, and nucleophiles. First one, free radicals. Free radicals means substances or species which contain unpaired or single electron are called free radicals. Free radicals are generally produced from homolytic fission. They are highly reactive and short-lived compounds, for example, H dot, Cl dot, Br dot. Next, electrophiles. Electrophiles means electron-seeking agents are called electrophiles. In general, electrophiles are electron-deficient compounds and it undergo reactions with high electron-dense compounds. Electrophiles means electron seeking or electron attracting groups. It is denoted as E plus. For example, all positively charged ions or cations are act as electrophile. It's 3O plus, Cl plus, Br plus, H plus, NO plus, R plus. Some neutral compounds are also acting as electrophiles. For example, BF3, AlCl3, FeCl3, SO3, RCOCl. In that neutral compounds, they are having one empty orbital. This orbital abstracts the electrons. Nucleophiles. Nucleophiles means nucleon seeking agents are called nucleophiles. Nucleophiles attract nucleus or positively charged centers. That nucleophiles means nucleon electron rich compounds. Nucleophiles are generally electron rich compounds. They donate electrons to the other substances. Example, negatively charged ions or anions or act as nucleophiles. For example, Cl minus, OH minus, Cn minus, RCO minus. And neutral molecules in which lone pair is present on central atom, they also act as nucleophiles. Yeah, HO2, NH3 or NH2, OH, ethers, they all are nucleophiles. Nucleophiles means nucleon electrons rich compounds. Electron rich compounds nucleophiles is denoted as Nu minus. And bond polarization. Bond polarization involves electron displacement from the main position or electron redistribution in the bond pairs. Hence, they are called as a displacement or electron redistribution. In generally, the diatomic molecules are classified into two types. They are homodiatomic molecules, and heterodiatomic molecules. In homodiatomic molecules, for example, like H2O and Cl2, the electron pair which holds at the atoms is equilibrium, the equidistance from the centers of two nuclei. Because of these two electrons are having same electronegativity, they are called pure covalent molecules and the bonds are called pure covalent bonds. In homodiatomic molecules, the electron pair is present on equidistance from the from the centers of two nuclei. Only the reason is these two centers or two nuclei or two atoms are having same electronegativity. Then heterodiatomic molecules, the electron pair is not equidistant from the centers of two nuclei of two bonded atoms. This is due to the difference of their electronegativity. Here in heteroatom, two different atoms are bonded. For example, HCl. For example, HF, HBr. Here you can observe this HCl. In HCl, hydrogen and chlorine is not having same electronegativity. In HBr, hydrogen is fluorine is not having same electronegativity. In HF, hydrogen, fluorine electronegativities are different like this. The electron pair in these two different electronegativity containing compounds are combined with a one bond. The electron pair or the bond is slightly shifted or slightly nearer towards the more electronegative atom because the greater electronegativity or greater attraction. For example, if you can take this example A and B, A and B, here A is having less electronegativity and B is having more electronegativity. Here more electronegative atom B attracts the bond pair electrons towards B side. That's why B is having a partial negative charge, and A is having partial positive charge. That means the more electronegative atom acquires partial negative charge and less electronegative atom gets partial positive charge, which leads to bond polarization. This type of molecules are called polar molecules and bonds are called polar covalent bonds. Here the bond polarization is indicated by an arrow like this, by an arrow, positive positive charge to negative charge. Here this is partial positive charge, this is partial negative charge. That means more electronegative atom and less electronegative atom. For example, HCl, HF, SiO2 like this. Here, for example, you can observe HF. HF, here hydrogen is having partial positive charge, fluorine is having partial negative charge. Because of fluorine is a more electronegative than hydrogen. Fluorine is a more electronegative. That's why here fluorine is having negative charge. This is the bond polarization. Thank you.